Hi, Miss Summer here with 12.4. We're going to do 12.4 in two parts. This part is finding angles using tangents and secants. We've seen tangents before, but we haven't seen secants, so let's talk about that. Well, first, we actually have seen secants a little bit because a chord is very similar to a secant. A secant goes through a circle and hits it at 2 points. It's a line. A chord is part of a secant, or what we might call a secant segment. So we're going to treat a chord just like a secant. So anytime you see the term secant, it will apply to chords as well. Here's one of our first theorems in this section. The theorem states that if we're looking for this angle, and it is formed by two secants, here's a secant going this way or this way. Now notice I dashed the lines outside because what if they're not showing? What if those just disappear? Well, now we have two chords, but the theorem is still the same. They form an angle, and the important part is the angle's vertex is inside, but they're not at the center, so they're not central angles. So angle 1 is not equal to angle x. Angle 1 is off center. It's not at the center. So what we say is that angle 1 is the average of its intercepted arcs. So angle 1 and its vertical angle over here have the intercepted arcs y and x. So we can add x and y together, divide by 2, and find angle 1. Now, that's our first type of angle. There are a few different types. We could have a vertex in the center, but we can also have one outside the circle. And this gets a little tricky. Because there are three ways that we can have a vertex outside of a circle. First, we could have two secants. And there's what I mean by a vertex outside of a circle. And you're like, these are secants? I thought they had to be lines. Well, just imagine. They continue. So these are kind of secant rays, or secant chords inside the circle, but they do meet outside, and that's where the angle is. We're looking at this angle 1. This angle 1, here's the x and the y. But instead of adding and dividing by 2, we would be subtracting. So angle 1 is angle x minus angle y. Now, I'm going to sort of convert this over. All of the ones in my notes use x and y. But consider this. You don't want to put a smaller number here. Oh, I forgot divided by 2. Excuse me. X minus y divided by 2. X has to be the larger number, y has to be smaller. They're not interchangeable. So what I often do is I say the big arc, which is obviously further from the angle, and the small arc divided by 2. Big arc minus small arc divided by 2. Because the order does matter. You cannot put the smaller arc first. And if they don't give you the numbers, you can tell which one's the smaller one by the one closer to the angle, larger away from the angle. Now, I said there were 3 of these. Well, what does the second one look like? Still uses the same formula, but it could be a tangent, or say, again, these dashed lines, it doesn't have to continue. We just need a tangent and a secant, or a secant segment, and then we have x, y, or as I was just saying, bigger arc minus smaller arc divided by 2 gives you angle 1. Again, bigger arc minus the smaller arc divided by 2 gives you angle 1. Well, what would the third circumstance look like? Because we have two secants. We have a tangent and a secant. Well, we could have two tangents. If if we have two tangents, kind of goes back to that sort of ice cream cone that we were looking at before. And the ice cream cone problem, we said, hey, these tangents are equal. Sure, these tangent segments are going to be equal, but we're talking about angles now. So if this would be the bigger arc, and this would be the smaller arc, and this would be angle 1. Now, one of the things that could happen is if they just give you the angle, the bigger arc could be defined as 360 degrees minus the smaller one. That's certainly possible. Don't worry, we'll get to an example like that and I'll explain further. So we could have two secants, tangent and a secant, or two tangents, but what they all have in common, why they all use this formula, is that the vertex of the angle that we're looking for is outside the circle. So let me do a quick summary, just using one picture, because we're still going to be using inscribed angles from the last section, 12.3. If you have an inscribed angle, vertex on the circle, and that's not very clear. Let me do a better job writing that. So if angle 1, vertex, this one, where's the vertex located? On the circle here, then we just take the arc and divide by 2. If our angle is located inside the circle, so now we're looking at for angle 1, we take our two arcs, x and y, or we take x plus y and divide by 2. So that's for a vertex inside the circle. So that's where our vertex is. And we do x plus y divided by 2, and that's to find the angle. Measure of angle 1 here. Or, and I'm just going to draw one of the three possibilities. If our angle is outside, sorry, I should have drawn that a little bit bigger. Angle 1, vertex outside the circle. And we're talking big and small arc. Measure of angle 1, big minus small arc divided by 2. And that is for a vertex outside the circle. So the vertex of the angle will determine which are you going to use. Are you just going to take the arc and divide it by 2? If the vertex is in, are you going to take the two arcs and divide by 2 once you add them? Or if the vertex is outside the circle, subtract the arcs and divide by 2. So that when I refer to where is the vertex, that is what's telling me which formula to use. Okay, let's jump in and do some problems. All right. Let's get that straight now. Let's start with example A from the notes that I am using. So if you printed the notes, or right back to them. All right, this one says, what is the value of x? Oh, since the vertex is inside the circle, we add the arcs. The arcs are 90 and 46, and divide by 2. So to find x, we're just going to solve that. 90 plus 46 is 136. Divided by 2 is 68. So our missing angle and its vertical angle are both 68. Next one up. We have our 20-degree angle outside the circle. we're looking for Z. And on the exterior of this arc is 95. Well, where is the angle located? Outside the circle. So this is a big arc minus small arc divided by 2 would be our angle. Our angle would equal to big arc minus small arc. Big arc is 95. The small arc is Z. Notice we're not solving for the angle this time. The angle is given. Our angle is 20 degrees. So I'm actually doing a little working backwards for the algebra. So multiplying 2 on both sides, this 2 goes away, and 95 minus Z is equal to 40. So Z, I just moved it over, so now it's positive. Subtract the 40. Z is 55 degrees. We can sort of check that. 95 minus 55 is 40. 40 divided by 2 is 20. So big arc, 95 minus 55. 40 divided by 2 is 20. That works. All right, so let's do a few more. I've got plenty of these to go, and I picked a couple of slightly more complicated ones from the textbook as well, and hopefully those will help. So this one is formed by 2 tangents, but where is the angle? Its vertex is outside the circle. Again, I have the angle, and we're using big arc minus small arc divided by 2. That is our angle. Well, our angle is 70. Our big arc is W. How do I know W is larger? Well, it's outside. The one that's closer to the angle, closer on the inside, is smaller automatically. So W minus 110 divided by 2. 2 times 70, 140, multiplying both sides by 2. W minus 110, add that up. W is 250. Great, I made it on the screen. I wasn't so sure for a second. So 250 minus 110 is 140, divided by 2 is 70. That checks. All right, next one up, another one with an angle outside, but this time the angle will be missing. Finally, so we're looking for angle Y. Outside, we have angle 30, and we have angle 110. Again, if the vertex is outside the circle, big arc minus small arc divided by 2 equals the angle. 110 minus 30 divided by 2, that's what Y is going to be. We don't have to solve backwards, we just need to solve this. And 110 minus 30 is 80, divided by 2 is 40. Hopefully you're feeling a little more comfortable with evaluating and knowing which formula to use. Okay, let's go back to one where the angle is inside the circle. Remembering that when the vertex and the vertex of the angle, or the angle, is inside the circle, we will add, not subtract. Some of you might say, well, what if that's at the center? Well, if they don't tell you it's at the center, you are using the formulas that are given. If the vertex is at the center, then it's just a central angle, and you don't have to do all of this. So, vertex in here, so that is add the arcs. For the angle, you add arcs and divide by 2. What are the arcs? X and 30. Well, we certainly can't add x30 and divide by 2, but we already know the angle is 35 degrees. So we're following the angle, 35, add the arcs, x and 30, divide by 2. So we have to work backwards, multiply by 2, 70 equals x plus 30. Subtract the 30 and we get 40. And now we have our 40-degree angle. 40 plus 30 is 70 divided by 2, 35 here, and it's vertical as well. right, so now I'm really going to throw you a bit of a curveball. I had mentioned when we were doing the formulas, I threw in a 360, and then we're going to throw one in again. Let's say here's our Earth, and there's a satellite way far away. Probably I should make it even further, but I only have so much room to work with. So our satellite S is pretty far away. And the view from that satellite down to Earth, it has a 17.5 degree angle. So we're going to find out how many degrees X it can see of Earth at one time. What can it see? Well, notice I don't have this arc. I previously had two given degree measures, either two arcs or an arc and an angle. Here I don't have that. But the one thing about two tangents is this. Two tangents have the arcs that are the complete circle. So this part of the circle can be defined as 360 minus this arc, X. So now we have two expressions to name the arcs, and we can follow through with the angle is equal to the big arc minus the small arc divided by 2. So our angle 17.5 is equal to the big arc, 360 minus X, minus the small arc. So this is our big arc minus the small arc. That's why it says minus X twice, divided by 2. So we can sort of simplify this pretty quickly by multiplying by 2, 35 degrees. 2 goes away here, 360 minus, and there are two negative x's, or minus x's, so minus 2x. So I'm going to sort of swap places here. 2x is equal to 360 minus 35. Let me go ahead and keep that going up here. So 2x is equal to 325. And then we just divide by 2. And we get 162.5 degrees. So a satellite that has that focus or degree of 17.5 degrees, so maybe it's a satellite that is a camera looking down at Earth, maybe Google Earth, that satellite can see 162.5 degrees of the Earth's surface. Okay, so that can be a little tricky. Just remember, if one of these values is missing and it's a tangent, then you can define it as 360 minus X and X. If you have two missing values and they only give you the angle out here, that's the type of problem you're looking at. All right, so let me switch gears for a moment to our textbook. There are a few problems in our textbook that I felt were harder than in the notes. So I'm going to pick a couple of those, and I'm going to bring in some of those inscribed angles. We've been working with angles that had a vertex inside the circle and a vertex outside the circle, like this one. But what if we get some pictures where we have all three, an inscribed angle and vertex inside the circle or outside? Well, let's take a look first at one of these. This is odd number 7 on page 562, just in case you wanted to look it up, 562, number 7. So we have a tangent over here, an angle outside the circle here, and another tangent. Good. Okay. So that looks pretty reasonable. They want us to find arc X, angle Y, and they give us 160 here and 50 degrees here. Okay, so sort of stepping back first to our lesson from 12.3. If we're going to find angle Y, it's really helpful if we have its arc. Right? Well, if we know that the circle is 360 degrees and we know 160, if we can find x, then we can subtract those two and get the arc for y. So that's a possibility. So let's go ahead and find x first, and then we'll be able to do that. Now, x is the arc, this arc, and this arc. If you kind of ignore that, that's the exterior angle that we've been working with. And the angle, 50 degrees, is equal to the big arc, 160, minus that small arc x. Notice they're both in the mouth of that angle, going to 50, divided by 2. Big arc minus small arc divided by 2 is the angle. So 100 is equal to 160 minus x. Swapping that x over here, that makes it positive. And 160 minus 100, x is equal to 60. So now we have 60 degrees. So back to finding y. This part of the circle is 60 plus 160. So we have 220. So if this is 220, the whole circle minus 220 is 140. So this part right here, 140 degrees, this arc. So angle y has to be half of that. Angle y is 70. So there are our two answers for that. And if you missed something in there, you can replay me and watch this again. All right, next one up. This one's going to definitely look crazy because we haven't seen any like triangles, pentagons, hexagons. So let's do a circle with a pentagon in it. Sort of a lopsided circle there. Let me do a slightly better job. Now, I may not have done a great job of getting a regular pentagon, but that's okay because we can make it have equal sides by just doing that. And we don't have to rely on my drawing skills, thank goodness. Now, we also have in this picture a tangent going through one of the vertices, and they're asking for angle y here, this angle, okay? And they're asking for angle or arc x out here. Now, one of the things that we may have forgotten about, and we use this way back when we talk about arcs, we've got 5 arcs here, okay? And we have 5 chords here, right? Well, there are 360 degrees in a circle, so x is just 360, and let's just divide it up 5 ways, because if the chords are all the same, that means the arcs are all the same. So 360 divided by 5 gives us 72 degrees for each one. Now that's going to be pretty important for getting angle y. This arc is also 72 degrees because it's one of these 5 72-degree angle arcs. So that means y, the angle that is on the vertex is on the circle. It acts like an inscribed angle, even though it's not quite inscribed. It is 72 divided by 2, or 36 degrees. So that's my y value and my x value. All right, and this could be a triangle. It could be a hexagon. You just have to split those 360 degrees up to see each of those arcs. All right, let's move it to one more type of problem, possibly, yeah, just one more for now. We're going to do sides as well. I'm splitting this section because there's a lot to do. So here's our last one for angles. So we have a diameter. The diameter, we have angle X on the inside here, 60 degrees here, 70 degrees here. And then we have, hopefully, I was trying, yeah, that's about right. We have a Y value, Y degrees here, and 53. All right, just double checking my picture. And we're looking for X, and we're looking for Y. So this is where they just put two different angles in the same picture. If you separated them out and you just looked at this picture by itself, or you looked at this picture by itself, it'd be a little bit easier to see. But let's start with X. X is an angle formed by an angle inside the circle. So we add the arcs. These are the intercepted arcs that go with these angles. And you're like, but X isn't one of those. Hang on, we're almost there. One extra step and we'll get to that. So 60 plus 70 divided by 2 gives us 65. Now that's not X, but it's almost X. This is 65, so is this. You're like, wait, if these are vertical, this is a linear pair with that. Yes. So 180 minus 65 will give us that X value, and that's 115. Okay, now let's look at Y. Ignore X for a moment. X is 115. I apologize, I don't have a second colored marker, but they don't actually show up very well on video. Now, keep in mind, this is the arc for for Y, right here. The arc, the second arc, is this arc, because that is where these tangents end. And when the angle is outside, we're talking about the angle is equal to the big arc minus the small arc divided by 2. Well, the angle is 53. The big arc out here is half of a circle. See that diameter? So that's 180. So that diameter sneaks up on you sometimes. Y is the small arc, because as we go in from that, Y is the next arc in there, then the angle. So big arc minus small arc divided by 2 is equal to that angle 53. 2 times 53 is 106. Equals 180 minus Y. I'm going to put the Y over here so it's positive. Swap it with the 106. And Y comes out to 74. So now we have our 74 degrees and we have our 115 for X. So when they put more lines and more things in the picture, you really have to search and look for your angles and ask yourself that question. Where is the vertex of the angle? Is it on the circle? So I just take the single arc and divide by 2. Is the vertex of the angle inside the circle, like this one, where I'm adding the arcs and dividing by 2, possibly looking for that linear pair? Okay, a little curveball there. Or is the vertex of the angle outside the circle, where I'm doing big arc minus small arc divided by 2? All right, good luck to you, and I will see you for section 12.4, solving for sides, the next portion of this. Bye now.